Hey guys, we're continuing with our review of different forms of alternate energy, specifically on the inverter UPS side. We have previously reviewed the Mecer 2400 VA inverter system. That unit remains one of our most popular units. It's with several of our clients and works really well. I personally still have my unit and I've had no issues with it. Today we're going to be looking at two inverter solutions from Mecer, branded as Kool Energy. These units are pure sine wave 1000 watt units, with the unit on the left having a single 12 volt battery and a unit on the right having a dual 24 volt battery setup. These units I've come across due to demand from clients and having the ability to have pure sine wave to run additional items such as fans and oxygen concentrators, as well as fridges. Okay, let's have a closer look at the 12 volt 1000 watt unit. On the left hand side we have a large display which contains all the information from the inverter on the AC side of things. It also has 3 LEDs up top. We'll talk about that in a moment. And the significant difference on other inverters is it actually has direct DC outputs, basically feeding off the battery. So you don't need to run the inverter to power small DC loads. You've got a switch to turn that part of the circuit on. You have two 12 volt DC outputs, which is typically for your Wi-Fi and fiber routers and so on. And you have two 5 volt DC 2 amp outputs for charging your mobile phone. Just a comment on the casing. It's quite compact, it comes in with wheels, the battery is in there, the inverter is up top, completely integrated. I'll post some parts of the manual as well in the video, so just put that aside. So on the business end, where all the magic happens, you've got a fan which cools the inverter, 2 AC outputs. You've got an AC input which then powers and charges the unit. You've got a typical breaker like most of the systems, and then the really cool stuff. So this unit has breakers to cut power to the battery, which is a really good safety feature on it. It has a battery extension output, so you can add an additional 12 volt battery which would feed into there. It won't fit into the casing, so it would just lie around, which may not be ideal, but in a situation where you do need more power or your power outages are longer, you have the ability to extend. And then finally, the really cool side is it comes in with an MPPT solar charger in it where you connect your solar panel to. The small one has a very small solar charge controller, and that would be a panel of about 200 watts. If you're drawing a load under 200 watts, like in your work from home setup, then a 200 watt panel will be more than sufficient to get the battery charging and utilizing some of this beautiful sunlight that we have instead of using utility power. Okay, so we'll go ahead and turn it on. So let's flip the breaker on, and that gives battery power. Swing this around and let's have a look at what we have. So now the LEDs are lit. It shows that we have DC output on these sockets from the battery. The battery's got a green light, which means that it's fully charged or available. And solar isn't lit as we don't have a solar panel plugged in. All right, let's turn the inverter on. Okay, there's an initial exhaust fan, like with many inverters, and a beep to inform you that it's on, which is soon followed by silence as there's no load on the unit. On the display screen itself, you've got your output voltage, 220 volts at 50 Hertz. Your input voltage is 0 as I've not plugged it in yet. And you've got some information about what's really happening here. Let's plug it into the AC so we have a broader picture. Okay, so let's have a look close at what's really happening on the screen. You've got an input voltage on the left of 220 volts and your output of 220, which the inverter is producing should you go into inverter mode, right? On this nice little graphic, this is your AC symbol, which is flowing into an AC-DC converter and charging your battery, as well as the AC is bypassing that circuit and providing power to your load. This shows the strength of the load, currently less than 25%. Okay, so what really happens? So I'm going to simulate a power interruption by turning off the AC. So like with the previous inverter videos, the unit seamlessly switches over onto battery power. So here you can clearly see the battery now, which is at 100%, is going through a DC to AC converter, also known as the inverter, to your load. And I'm going to end it there for this little video of the small unit. You guys have watched my previous video on how an inverter works and the transition. I just wanted to provide all of you a review on this product. What I do find a few perks of it is that it is definitely quieter than your modified sine wave inverters like the Mecer 720 and 1400 watt units. And that's because it's pure sine wave, so it's got improved components inside to allow it to be quieter. I would have liked to have put this unit onto a solar panel, but the panels that I currently have in stock are from 275 watts upwards, which generate around 30 to 40 volts, and that would be too much for this unit. So we will be testing that in a separate video on the larger unit.